So, 10 years ago, 2006, I was actually listening to a podcast called The Java Posse. Who knows the Java Posse here? Anyone? Okay, a few of you. Yeah, so 10 years ago, I was listening to that podcast, and they talked about a continuous integration server called Hudson at that time. And I thought, okay, good, sounds great. I have my build script already in ARNT, so why not having a continuous integration server? So I tried it out, installed Hudson on a server, and pointed that to my CVS repository at that time, and then showed it my ARNT script to build my stuff, and I checked in code, and I thought, wow, this is really magic happening, because this thing showed me that my build failed, so my test failed. I thought, wow, this is so amazing. I just checked in code and it told me that my test fails? Wow. I thought at that time, this is really the rise of the machines 10 years ago. Where are we 10 years later now? We're still using continuous integration server. Now it's called Jenkins and not Hudson anymore, or Bamboo, or whatever you use as a continuous integration server. And yeah, we're going into the direction of continuous deployment and stuff like that. So things are getting more and more automated. But what's with the rest, actually? The rest of software development. I mean, we're doing not just building stuff and deploying stuff. We're doing a bunch more of stuff in software development. So I thought doing a talk around that would make sense, would be very interesting to see. So I talked to a lot of people in the software industry and put together some cool bots, and I want to show it in that talk. But first, I want to give you a disclaimer what this talk is not about. I already told you, this talk is not about how you build a better build pipeline. Not about your build pipeline. There are other talks about that. Very good. Go into deep. This is not the talk. I will also not talk about some chef and puppet scripts, some cool deployment scripts, how you set up your environment and stuff like that. That's not what this talk is about. And also, I will not talk about how to write better automation scripts, which language should you choose, what are some tricks to write some cool scripts. This is also not what this talk is about. Instead, what I wanted to show you is, I want to show you what's cooking right now in the industry, what people are doing in terms of automating their software development. Okay, before I start with software development and automation in software development, I want to talk a little bit about how does the rise of the machines look in our day-to-day lives. What's there? What are we using in our day-to-day lives in terms of automation? Automation is taking over our day-to-day lives. For example, this thing here, the vacuum cleaner, automatically, if you're not home, cleaning your house, pretty cool. I want to have one of these things, but my wife keeps telling me, no, we can use, it's pretty expensive, but I think it's really cool if this thing is running around doing all the homework when I'm not there. So, but yeah, maybe next year I can convince my wife to buy one of those. Or the Nest, where you're driving home and the Nest will recognize that because it's connected to your mobile phone and turn on the heating or turn on the air condition. Pretty cool stuff. It knows, and then when you're home, everything is cooled down, so pretty nice thing, the Nest. Or even better, self-driving cars. Yeah, Google is building these and trying out these. I think we're not really there yet. It takes us a little bit more to have really self-driving cars around on the streets everywhere. But yeah, it's a good start for automating our day-to-day lives. So where we are is more in the automotive industry, is more automobile industry, is more. Volvo has started with that. It is an automatic human detection. So they have built in a human detection. They've built in a human detection in their car, and it stops when there's a human in front of the car. So they have built that in. So this is where we are with automatic cars, and you see that here. Oh my God. Damn it. I think we shouldn't trust the robots too much here. And that's so true also for software development. It's good that we have automation, but use our brains to see what we automate and how far we go with automation right now. So that leads me to the rise of the machine in software development. Where are we in software development with automation? I'm Sven. I work for Atlassian as an evangelist, so traveling around, talk about automation and some other cool stuff that the industry is doing right now. And I've been working in software development now for almost 16, 18 years, and I've seen some stuff coming up in automation, and this is totally my own story about my own history about automation. So Sven's story of automation in software development. 1996, I was studying at that time, and I was using some build scripts, some make scripts at that time, and then 1998, I was actually using my first GUI builder. We still don't have any GUI builders or any good GUI builders right now. We still code everything. But at that time, I thought, this is pretty cool. I can just drag and drop, and it generates the code automatically in the background. At that time, I couldn't really change the code because it was a Microsoft product, and they didn't allow me to change the code. I don't know, but that was at that time. 2001, I saw JUnit coming up. I thought, okay, great, it's running some code, some tests. How big can that be? But it really changed the way we are developing software. I didn't see that at that time. I saw that later, that's really changing the way we develop software. 2004, I know Arndt is a little bit older than that, but then I was first starting with doing some build scripts and scripting everything up, letting my test run in a script and my build run in a script. Pretty cool, later Maven. 2005, I was switching from Ball and JDeveloper. Anyone knows Ball and JDeveloper here in the audience? Oh, there are a couple of you. Wow, cool. Yeah, so I was switching from that to Eclipse, and I thought, wow, this refactoring, that I can just refactor a method and it changes all calls of these methods, and that's pretty cool. JDeveloper didn't have that feature, but I thought this is great in automation. 2006, as I said, Hudson, later Jenkins. 2009, Puppet came, and Chef, and automating all this deployment pipelines and stuff like that. Also pretty cool. 2011, I was using some Git hooks, and I will tell a little bit about Git hooks later, what we do at Atlassian with Git hooks. And that pretty automated my whole coding flow, helped me with that. And 2013 came Docker along. And I will also talk about that a little bit later, how Docker helps us in terms of automation. But if we think about automation in software development, we constantly think about deployments, builds, and maybe you have some small scripts running on a server somewhere that is doing some cron job or something like that. But actually, this is just the tip of the iceberg. We can automate much, much more. Engineering health. You can automate your support, actually. Stand-ups. Stand-ups, Sven, really? This is some human interaction. Can you automate that? I will show you later how to do that. Code reviews and operations. So there's a whole bunch you can automate besides continuous integration, continuous delivery. And I put all this stuff together this is my agenda here. So we have some coding bots, some test bots, some operation bots, service bots, and some bots that are doing reports. And but the first bot I found, or the first automation I found, has actually nothing to do with all these bots, so I start with that. And it's always when we start with a new job somewhere. So you start a new job, and then you were going to show around the company and greet everyone, say hello, and he's doing that, and she's doing that, and stuff like that, and this is our architecture. And after, I don't know, 2, 3, 4 hours in the new job, you think your head will explode because there's so much information, and you're happy that you are now allowed to sit on your desk and have your new shiny laptop or machine there, and then says, welcome, let's get started. Okay, what's the first thing you do? You install some bunch of stuff that you need for your work. So maybe some IntelliJ, Postgres, whatever you need. But that's just your tools. You don't know what tools you are using in this new company. So what you do is you ask someone, hey, what IDE are you using? What database are you using? What do I have to install? And These people in organizations, they have everything written down, of course. Good documentation to onboard new people, and we have the same at Atlassian. So you see here, setting up a development environment for a brand new Mac. That's a page in our Confluence instance that new people have to look at and do all these things. And it tells you a little bit what you should do. So it says, set up your Bitbucket account, upload it in the right places, stuff like that. You go on and on and on. And it says, hey, configure Maven. And then if you have configured Maven, the next step is let Maven download the internet for you. And we all know that takes a long, long, long time. And in between, when Maven downloads the internet, you can set up your IntelliJ IDE, and you can set up your databases, and then you go to the next step, and it says, if you're still waiting for Maven, you can read these blog posts here and find out a little bit more about it. Yeah, you probably have all done that, going through all the steps. And hopefully you have all written down the steps so new people have an easy way. But the first comment that is on the page, or actually the second comment, is, why are you not using Agent Charlie to skip a whole bunch of these steps? Agent Charlie? What's that? Meet Agent Charlie. That's our bot. And what you do is you go to that page, which links to Agent Charlie, download that script, execute that script, and Agent Charlie is doing the rest for you. So Agent Charlie is going in and downloads software, installs the software you need, and configures the software you need. So this is Agent Charlie. You don't have to care about what you have, where do you have to download something, and where's the latest version. It's all set up in Agent Charlie. So Agent Charlie here, what is Agent Charlie? Well, it's a bunch of Ruby and Shell scripts and Puppet scripts put together, runs on OS X and Ubuntu, and installs all these things and some more things for you, so you don't have to worry about that, and sets up your environment. And then, of course, you want to install some other stuff that you're used to, so go ahead and do that with the rest of the time. But what Agent Charlie saves you is the starting time. You just start Agent Charlie, and you can go to your colleagues, to your new colleagues, and have a chat with them and talk about that, talk about what technology they use and stuff like that. And Agent Charlie is taking care of the rest, which is pretty cool. All right, let's start with some coding bots here. Automate your coding phase. So if you're on a cocktail party somewhere, and people ask you, hey, what are you doing for your living? You say, hey, I'm a coder, I'm a programmer. And people immediately think, this is you. You're sitting there the whole day in a dark room and code. That's what you do. You code the whole day. In the morning, you start coding, and then you stop coding, go home, and start coding again in the morning. This is what people think, what we're doing day in, day out. But hey, we know we're doing some more stuff than that. Besides meeting, we're doing some other stuff too. So we're doing code reviews. We care about our deployments. We care about we have issues that we have to update. We're running our build servers. We're doing some branches and have to keep care of them, to create some branches, do some merging, resolve some merge conflicts, all these stuff. We're doing much, much more than that. But hey, we want to code. So let's get rid of some of these stuff. So what can we take out here? How about the issue tracker? We don't want to use the issue tracker, do we? It's necessary, but hey, you would think, hey Sven, are you stupid? You're from Atlassian, so you have this product called Jira. It's an issue tracker. Yeah, but let's have a look. So let's have a look at our issue tracker workflow. This is our issue tracker workflow. It's a typical issue tracker workflow. You have a to-do, it issues in to-do, in progress, it gets in review, and then at the end, you set it to done. Typical issue tracker process, you probably have kind of the same process if you use an issue tracker. So how about your coding workflow? How does that look? So this is our coding workflow. We create feature branches. So we have small living feature branches, 2 days or something, and then we merge it back. So we branch, we code, we refactor a little bit. We do a pull request, and at the end, we merge the code. So how does that work together with our issue tracker workflow? This is what we should do. We have a to-do, we set it in progress, then we create the branch, we code refactor, we do a pull request, we set the issue in review, we merge the code, and then we set the issue in done. This is what we should do. What we do is actually normally we create a branch, we code refactor, we merge, and then somebody says, what's this issue? Is that done now? And you say, oh yeah, wait, let me just update the issue. It's in to-do, it's in progress, and review is done. 2 minutes, your issue is done. Cool stuff. We tend to forget this. But as much as we think the coding is the most important thing here, and it is, we have to keep the team updated. The team has to know where we are in our software development. The team has to know where we are. So if an issue is in review or this issue is already done, the team has to know that. So how do we keep the team updated? And we have been thinking about that. How can we make this process a little bit better? And we've been thinking and said, okay, we're trying some stuff out and found that here, the epic motive. So you put it on your head, and it reads your brain, your thoughts. And you can control actually Jira. This is an experiment. You can control Jira just by not using a mouse, but just with your thoughts. You can just think, the issue is in progress now. And it automatically drags it over. Isn't that cool? That's great, isn't it? And drags it back. You don't have to use a mouse. But sad that is, we still have to open the issue tracker. We just don't use a mouse. So that doesn't really help us that much, even though it's pretty cool. Doesn't really help us that much in thinking about updating our issues. So what a lot of tools give you is this here, smart commits. If you use GitHub issues, Jira, Utrack, Trello, Bitbucket, you name it, you can use this smart commits. And in your commit message, you mention the issue key and you give it a command. And then it updates the issue depending on your command. So how does that look like? So you make a commit message and say, hey, ticket number, start progress. And the issue tracker can read the commit messages and drags the issue automatically over. Or start review. Or even fixes issue number. This is the GitHub issues notation here. And it drags the issue automatically over. So you control the bot by your commit messages, which is pretty cool because there's no tool switching anymore. You stay in your IDE or wherever you do your commit messages or in the terminal, and then you type in commit and type in the command for the issue tracker. But still, the robot is still receiving just commands. You still have to think about the issue because you have to mention it in the issue key. So the robot is still receiving commands from you, just with you don't have to switch tools anymore. So let's try to fix that. And that's actually built in the latest version of Jira and Bitbucket, if you use that. And I'm sure the next vendors, the other vendors will follow on that because it's pretty cool. What you do is you create a branch and you mention the issue key in the branch. So what they then do, these tools do, they associate this branch with this issue, which is pretty cool. So it knows, okay, there are some commits already on the branch. There's a branch created, so the developer is currently working on that. So I push the issue over. Then you do a pull request, and the issue is dragged automatically over because it sees the issues. The code is under pull request now, so we drag it over, and then you merge the code, and you don't have to do anything, and it's just automatically updating the issue, and it's done. When I first heard the people in Sydney are working on that, I was going like this, yay, that's so cool, I want to have that. And it's pretty cool. But as I said, now it's working in Jira and Bitbucket, I'm pretty sure that the other vendors will keep up and do the same thing. All right, so another little workflow helper that I have for you. This is our workflow. We branch, pull, merge. I already told you that. And these little workflow helper helps us with that workflow. So let's assume you have this new cool guy on your team, and he's not following your process. He's committing directly to the master branch, always. And then, which he's cool. He knows what he's doing. But one day, maybe he introduces a bug. So the build gets red on the master branch. No big deal, he says, hey, I'm so cool, I can fix that in minutes. So he writes code, fixes it in minutes, boom, green again, awesome. Everything is good, isn't it? Except there's a developer following that rule, creating branches. And this developer actually fixes something, does some code, runs the build, and then, red. Why is my build red on my feature branch? I didn't change anything that breaks that code. I I don't know. So that's a really, really, really bad surprise that you have there. You just, wow, what was happening here? And you look around, and maybe it takes you 10 minutes to figure out, oh, the bug was already in the master branch. So I didn't introduce it. So you shouldn't have these bad surprises. So let's fix that. Let's add a bot to the problem. And it's actually a Git hook that we have written, and it prevents us from branching from a red build. So we have combined the build system with the Git hook, and the Git hook is looking at our build server and see, okay, the master branch is currently red. You're not allowed to create a branch from the master branch until the build is green again. So this is my first little workflow helper that helps us with that. The next thing is, who should review my pull request? So your code is done, and then now you want to have the code review, so you're doing a pull request. And who's the best person to review your code? So I invite always my friends because they think they're friendly with me and say, Sven, you write cool code, everything is fine. But that's not the best thing to do because you want to have honest feedback on your code. So who are the best people to look at your pull request? It's actually these people here. So if you look in the commit history, in the file that you currently changed, these people are the expert for that code. They know that code. They have changed it. They have looked at it. So these people are the best reviewers for your code. But looking at if you have changed 10 files, who are the best people? You have to look through all of them and invite them. Yeah, you get it. We have a bot for that is doing that. That's looking on all these reviewers and say, hey, and we built this. It's a free add-on for Bitbucket Server, and it's called auto-suggest reviewers, and you can just put it in, and it suggests reviewers based on these facts. Who has committed to that file the last time, or who is the original author of that file. And it helps us to invite always the right reviewers to the code. So invite the right reviewers, other little bot. And then we have this workflow, and we are now a little bit larger company where we say, okay, a pull request has to be approved by at least 2 people. And I think we are 800 developers right now, so we have to kind of a process. So what our process is, we invite maybe 5 reviewers, and if 2 have approved the pull request, we're good to merge. We are allowed to merge, and we have built that into a Git hook, and it allows us not to merge before there are 2 approvers on the pull request. So a minimum of amount of approvers for the pull request. That's another little workflow helper that we have. So what about patching older versions? So we're doing on-premise software, so there are different versions out there in the world of our software. And if we find a bug in an older version, we have to patch that. We have to maintain that version. So how do we do that? This is our branch strategy for that. So we create a branch for each version, and we keep those branches. So we keep those, have those in our repository, keep those branches. And when we found a bug in an older version, or someone reports a bug, we create a small hotfix branch, just a branch, and then we fix it, and then we merge back to the release branch here. And now we have, of course, also fixed the bug in the other versions. So we do that by just merging it up to the least stable branch. So from the most stable branch to the least stable branch. Pretty straightforward process. But if you know Git, you also know that branching is pretty easy. And if you don't have a conflict here in the first time, in the first merge, then this is boring work to merge it all the way back. Probably there has nothing changed in that file, so it's very easy to merge it back, and that's really boring work. So what are we doing if we have boring work? We're adding a bot to the problem, right? So having that bot said, hey, I can do that, I can help. So what we do is actually we automatically merge these changes. So we merge it the first time, and then the bot takes over and merges this all the way back to the master branch or develop branch, whatever you have there. So, little workflow helper number 4, get some help with merge jobs. Have some auto merges. Let the bot take over. If the bot fails with auto merges and there's a merge conflict, of course we stop it and report it to the developers. All right, so this actually concludes my coding bots let's go over. Code is done. We merged it. Great. Now let's get over to testing. And what we're doing is, as software developers, we are engineers. We want to create great code. So we are trying actually to create awesome code. Great, beautiful code. We want to be proud of our code. And you know that feeling. If you have really thought about the design, the class design, and said, there's an interface, there's an abstract class. Wow, this design looks so great. This class is so awesome. It just has 32 lines of code, makes so many great stuff. I love it. I really love that code. Wow, I'm so proud. You know that feeling, do you? Yeah. And then you go on vacation. And come 1 month later, you come back and you want to look at your awesome class and you see, what happened? What the happened to my awesome class? Oh my God. People also thought this is an awesome class, so let's add some code to that class. And these things happen to code, no matter what we do. Code get messy over time. People put something in. This just happened. The code quality actually it decreases over time. We can't do anything. I mean, I've been working in so many projects, and I've seen that all the time, that code quality decreases over time. So test coverage goes down, and deprecated methods goes up. You know that. So your metrics getting worse and worse. Why are software developers doing this kind of stuff? I mean, they don't write bad code on purpose. We don't write bad code on purpose. We don't say, oh, let's mess this class up. No, that's stupid. We don't do that. Maybe if we hate that developer that has written that class, maybe then. But no, we're engineers. We want to create great code. But I think what happens is that developers are trying to solve problems. And we are so in the tunnel of solving the problem, and we have a deadline, and we want to get it out to the customer, the value to the customer, that we think, okay, good. We just put it in, and it works. Great, let's move on. So what can we actually do? So we can assign a worker on that and have say, okay, please look at the code quality, at the engineering health of the code. Control that. And we're calling it Dr. Code. So Dr. Code is really measuring the engineering health all the time. Of course, Dr. Code is not a real human. Dr. Code is a bot. And it actually started at Atlassian. It started when we were moving from JUnit 3 to JUnit 4. So some developers said, hey, let's move to JUnit 4. We don't want to use any JUnit 3 test anymore. So what we could do is, of course, to refactor everything to JUnit 4 would have taken us a lot of time. But we just said, okay, we don't want to have no more JUnit 3 tests. We keep those tests that we have. Okay, good. Maybe we're refactoring over the time, but please don't introduce any more JUnit 3 tests. So he wrote this little checker class that just counted the JUnit 3 test, compared it with a value in the database. Boom, if there's one more JUnit 3 test, you get an email. No, you messed up the engineering health here. But people thought this is so great, this is so cool, that they added more and more and more and more checks to that. And I don't know, now we have 50 or 60 checks that Dr. Code is checking for us. And then you get all the bunch of emails. Now, so what we do is actually, we wanted to give it a little bit social pressure. If you are caught by Dr. Code, you enter at Atlassian the Hall of Shame. Shame on you. What did you do with that code? Shame on you. So what we do is, and that's a little bit a cultural thing. We are fine with calling people out and having fun with that. It doesn't, and I agree, it doesn't really work with every organization, but we really put the picture of the developer on there and say, hey, you messed up something here. This is a warboard, big televisions hanging at Atlassian and showing. And this guy here in yellow, I don't know if you can see him. He's, I think, 4 times or 5 times on that board. And he said, Sven, if you go to Istanbul, can you exchange my picture? I said, no, you're in the Hall of Shame. Shame on you. Everyone should see that. Well, so saying that is you can of course fix that by fixing a JUnit 3 test and refactor that to a JUnit 4 test. And then you enter the Hall of Fame. And everyone wants to be famous. So that's great. So talking about engineering health, when we compare code as software developers, we are pretty good at seeing differences in code. Our eyes are trained to see the difference between an old version and a new version. We just have to look left, right, left, right. And you probably have all seen the difference in that code right now. It's this magic number here, the 20. Pretty good. But because we're developers and we are used to read code. What about design? What's the difference here from the old version to the new version? Okay, the resolution is not very good, so I make that short. Well, there's a difference here in the icon, the calendar icon, and if you have an eye for design, you probably can see that pretty fast. And but we're developers. But a designer can tell you, hey, this line is 2 pixels off, and you say, what? Yeah, it's 2 pixels off, and then you measure and say, oh yeah, right. Oh, sorry for that. So designers are actually trained to do that. So now what we can do, if we run our test, we can have a designer looking at the pictures and say, hey, this line is 2 pixels off. Or we have a bot for that compares images. So when we run our test, we make an image of the current software and compare it with an image in our database. And we do a pixel by pixel comparison. And if we found something, this bot alerts us and say, hey, there's something different here in that UI. Here's the report. So look at that and say, is that okay? Is that on purpose, or did you just introduce something? And it's very easy if you say, okay, you click on it and say it's on purpose. So you get this easy report where you can see, okay, version before that I have and the new version, and then you can say, okay, it's on purpose or it's not on purpose. So this bot helps us in comparing images. So image tests, we have some kind of a UI image test here. Of course, we have our unit tests that run, and then we have, that's pretty fast, and then we have a bunch of functional tests. And if you have functional tests, you know, these functional tests, they run very, very long for a long time. And we have a pretty old code base. Jira is now, I think, 14 years old, or 15 years old. And we have a lot of functional tests, and we think all these tests are necessary. So how can we make that shorter? The first thing that we did is, of course, put some metal to the problem. So we have more servers, running more servers, put them in the cloud, running them on AWS instances, and then we get the receipt from Amazon and say, oh, God, that's pretty expensive. But it makes things faster. It makes the feedback loop faster. But also there, if we run them on different servers, we have to slice and dice these tests statically. So we can say, okay, test block 5 goes onto that server, 1 on that, blah, blah, blah. But there's a problem in here if we do that way. We're always waiting for the longest test to run, the longest functional test. We're waiting for that. These servers here are pretty relaxed because they have run all the tests, but we're waiting for that one to aggregate the information and say, oh, okay, the build is green. So what we did is actually, we wrote, of course, a bot that helps us. It's a dispatcher bot. So we put all functional tests in there, we annotate them so we can find them, and then this dispatcher bot takes over, looks which servers are available, and dispatches the functional test to the free server here. So it looks more like this. Instead of having this long running jobs, we have very, very short running tests here. And at the end, we can see in a faster way, actually, saved a lot of time for us, that the build is green. Great. And we are happy. If the build is green, we're happy developers. Yay. What happens if the build is red? Well, we're not that happy, but hey, we caught a bug before it hit our customers, so that's great. So let's look at that. And then you look at the red build, and you see, why does this test fail? We didn't change anything in that code. So why did that test fail? And you cannot find out why it failed. So what are you doing? Anyone? You rerun the test, yeah. And then the test is green. And that's a frustrating moment because you just discovered a flaky test. And what does a flaky test say? It doesn't say anything. Maybe it says, okay, the code underneath is flaky, So we have to fix that. But flaky test, you can also leave it out. It doesn't say if it sometimes succeeds, sometimes fails. It doesn't say anything about the quality of your software. So flaky tests. And we have actually built a flaky test detector that detects flaky tests. So how does that work? How does a bot figure out that there's a flaky test? So what we did is actually, if a test is failing, our build server says, okay, good, let's rerun that test. Okay, it's ready, it's still red, let's rerun that test. Oh, now it's green. Huh, okay. So we just discovered a flaky test here. So what we do is actually, we continue the build. Okay, we just say, okay, it's not really fine, but we continue the build because it's a flaky test. And we put this test into quarantine. So next time we will execute that test, it wouldn't be executed anymore. But what we also do, because we have to fix it, we have to look at it immediately, is we create a Jira issue for it automatically and assign that to the author of this class. So this is our flaky test detector and helps us to detect flaky tests. And we tried it out with the Confluence team first, and in the first half year we put 817 tests into quarantine. We didn't fix them all yet, but we looked at all of them and said, okay, this is really a flaky test, so maybe we throw it away later. And this is really flaky code, so we have to fix that code immediately. But 817, and also think about how much time that saved for us, looking at the test and say, what failed the test, and rerun it again. A lot of engineering time that we saved by our flaky test detector. All right, let's move on here. And instead of test bots, we have tested now our software. Everything runs fine, great. Now we give our software to the operation guys. And we know these days are actually over where we just throw things over the wall and say, hey, here's the software, operation guys, have fun with it. It's now your problem. We don't do that anymore. No, that's a long time ago. We have DevOps. So developers and ops guys working closer together, yeah. But still, what we have is sometimes a slow feedback loop if we have that ops guys running the software, the infrastructure of the software. So if we have a problem here, figure out that there's a problem. The ops guys get called and say, the ops guys are looking at it. Maybe restarting the servers and say, didn't really solve the problem, so we're going to call the developers. And then the developers look at it and say, okay, it's our code that messed it up. So we change the code and the problem is gone. This is a very slow feedback loop because we have the ops guys in between. So let's get rid of the ops guys here. So problem, let's call the developer directly and say, hey, your service that you wrote, that you're responsible for, that failed. And then you look at it, fix it, and it's done. And we use actually PagerDuty for that. PagerDuty is a tool that you can use, and we use that. And PagerDuty is connected to Negios and all this ops services. And actually, what PagerDuty has, it knows which team is responsible for which service and calls the right team. So it dispatches it to the right team here that is responsible for that service. So that's great, but we didn't write a bot for that. That's just PagerDuty. But what we figured out is that we have to update PagerDuty all the time. I mean, we're doing services all the time. We're doing microservices these days. So there's a new service every day or maybe every week. And we have to update PagerDuty and keep that in mind. So there's a lot of configuration work in that, except it is not. We're not doing that. So what we instead do, we have a bot doing it for us. So how does that work? Well, so in our deployment descriptor, we tell PagerDuty which team is responsible for that service. And the bot is reading that deployment descriptors and adding it to the configuration of PagerDuty. So it's always updating PagerDuty with the latest responsibility for the team. So the right team can jump on the service that just fails. And that way, actually, we own our code end to end. We are responsible for our code when we write it, and also in production. Very important. All right, so we have written our code, and maybe we have done now our big feature that we want to get out to the public, and it works fine on the staging server, and we're sitting there waiting for it to come, that the day come, and the marketing team has set up everything and stuff like that, and then we can deploy our code. But then somebody comes to you and says, hey, wait, have you written the release notes? And say, yeah, the release notes, I always forget about that. The code works, but the release notes, okay, good, I have to do that. And if you want to really be sure what's in your code, you have to look at the commit history from your last release to the current release that you're doing. So everything here in between. And if you look at the commit history and you have mentioned the issue keys, you can easily find out which issue keys you include in your release notes, and take those description out and put it on the release notes. Except it could make it's a very boring work, and actually a bot can do that for you. So what a bot can do is read the commit messages, get out the issue keys, then grab the issue information and create the release notes automatically. And especially if we release daily or even hourly, we want to tell the people what we changed. This is pretty. You have to do that, because otherwise, if you do that manually, you be insane by writing release notes, or you have to have a person to write the release notes. So who's doing that? Hazelcast is doing that. If you look at their release notes, they have all their release notes generated out of issues, from the commit history to the issues to the release notes, and they are actually using GitHub issues. And GitHub issues don't have issue types, so they use the labels in GitHub issues to say this is a fix, this is a new feature, an enhancement, yada, yada, yada. Also, Zero Turnaround is doing that. Zero Turnaround uses Bitbucket together with Jira, and they use the issue types to say, okay, this is a new feature, this is improvement, this is a fixed bug, and they generate the release notes automatically based on that. And that's pretty cool. Of course, why is it good? Because there are no surprises. You don't have any surprises and say, oh, this didn't really, we didn't put that into our code. We didn't fix that bug. We thought we fixed it, but it didn't make it into this version. So it's really what is in your commit, what is in your code is really in the release notes. No surprises here. The other thing that you get is when you're writing the issue description, you think about, oh, that ends up in the release notes, so I better write a human-readable issue description here, not just write in something fast that no one understands. You think about, okay, people have to read that, so I write human-readable issue descriptions. And also, what you think about, what is the real customer value? What should I tell the customer? What's really important with that issue that we just fixed? What does the customer get out of it? So you think about the customer value by doing that. All right. Going from ops bots to some service bots. So let's do some automation in service. Okay, we have support. So support people are doing support, and we have that problem or the uniqueness that our software runs on different servers, so we cannot get the log files if somebody reports a problem. So we have to ask people for their log files, or upload their log files. So they upload their log files, then our support looks at it, and maybe in 60 or 70% of all cases, they really nail it and say, okay, this is the problem, here, go. But what's with the rest 40%? They have to call the developer and say, we couldn't really figure out, can you please have a look at the log files? And we are pretty good, not just at reading code, but also at scanning log files, and we can see, okay, this null pointer exception, I know that, and then, oh, what's with that one? Okay, there's a null pointer exception here, and you combine that with your system knowledge and say, okay, this might be the problem here. This might have failed, which is okay. I mean, we have to support our customers. Someone has to do it, and we know the system, so we can help them. But the problem is that it pauses our work. So we have to stop our work, do something else, and come back. And that takes time. I mean, coming back to our work and interrupting us, and we have goals, and this stops us really, and the customer has to be served immediately. This stops us from our work. So, I mean, I think you get what's coming now. It's a bot that is doing that for us, and we call him Hercules. So Hercules is actually scanning the log files and combine that with the system knowledge. How do we do that? So actually Hercules is a bot that just looks at Confluence pages. So we have all our knowledge base in Confluence, all our problems here, and there's a machine readable part of the page that Hercules can read, and there's a regex expression in there, and he can take the log file, look at the regex expression, found something, and suggest, oh, it could be that problem, and you solve it that and that way. And we're updating, of course, the knowledge base. Sometimes Hercules is not right, so we change it a little bit. And this thing is getting smarter and smarter and smarter, helping our support people to find the right solution, or trying to find the right solution. So the bot is suggesting something, the support people are updating the knowledge base, and the bots get smarter, you get it. And we tried also to put it just directly to the customer, so kind of self-service that they can upload their file, and Hercules is suggesting the problem. We wanted to make it real. We wanted to test it first with our support people, so now we're testing this with some people. And actually, one of the first people that tried it out wrote that comment. Well, fuck me, the robot was right. I increased the memory available for Confluence Jira, and things worked. Today is a truly magical day. Woo! Cool feedback. And our people that wrote Hercules were so proud of it that they created a t-shirt. We're a t-shirt company too. Well, fuck me, the robot was right, and running around very proudly with that t-shirt. Cool. All right, but it's not only that we're doing customer support. We're doing support for other people too that comes to our desk, even though we are just currently writing some great code and are in the tunnel of writing great code, and then someone comes and says, hello, can you help me with that problem that I just had? And I said, yeah, sure, I can, but now I'm out of my flow, and I have to get back again. So how can we? And sometimes it's really some obvious things that don't have to be solved immediately, that you can also solve when you get time. So Spotify is actually doing that. They have this self-service terminal where people can enter their problems, and it looks like this. So they have this. People come to the office or come to your room, your development room, and they have this desk here and say, if you have a problem, enter it here. If it's not, it have to be fixed in the next hour. If it has to be fixed in 3 hours, enter it here. And the cool thing is you get something physical back. So there's a printer, as you can see here, and it prints the ticket out with the ticket number, and you can go there and say, oh yeah, I got something back, because otherwise you just say, oh, that's another black hole. But you have something physical here. You can put the sticker on your laptop and say, hey, have you followed up on that one here? So, all right. So let's jump over to the last topic that I have, and that's report bots. So do some automatically reporting and feedback, give us feedback about what we're doing. Feedback, stand-ups, automating stand-ups. As I told you in the beginning, you think, Sven, are you stupid automating your stand-up? That's really the 10 minutes a day I got really human interaction. So this is really important to see what the other team members are doing and exchange some information. Yeah, that's true. But there are some things in stand-ups that make stand-ups pretty hard. And that's people are actually talking too long. Stand-ups sometimes take too long because people keep up their time and talk about whatever. Some people are doing that. And then sometimes you have to grab people and say, hey, it's 9:30, you know, we have a stand-up every day at 9:30. Why are you not there? Why do I have to catch you always in the kitchen and drinking coffee? So come to our stand-up. Then you have, if people work remotely from home or wherever location, and you have to set up a VC call, and that always takes time. And then working in different time zones where you have hardly an overlap in the time zone, it's pretty hard to do a stand-up, especially if your team is divided over the whole world, then it's nearly impossible to find the right time for a stand-up. So let's get these things fixed. And let's fix that stand-up takes too long problem first. So a team actually here has built this stand-up buddy. And it's a thing, you hold it in your hand, and it starts vibrating after a time, and that's the time where you have to stop talking and hand it over to your teammate. And we built it ourselves. There's little nano robots in there, and they vibrate. So this is a pretty cool way that stand-ups doesn't take too long, and everybody takes their time to do their stand-ups. The second problem is that people actually are missing stand-ups because, as I said, they're in the kitchen and always forget that it's time for the stand-up. So how can we fix that? Well, so a developer wrote actually an extension for Chrome, and it's called crontab, and you can set a time and point it to a URL, and it opens the tab and opens this URL, and we set it up to point it to a music streaming service. So if you're in the kitchen and hear AC/DC playing, you know it's time for your stand-up. We set it up one minute before the stand-up, so you know, okay, it's time, and everyone gets together and having the stand-up. And if you hear Taylor Swift playing, you know it's the market team stand-up. Anyway, we do use the same extension, of course, for setting up VC calls. So there's always the same URL for our VC calls. It's a fixed URL, and it opens this VC call, and you can on your big television that you have, our wallboards, and setting up the VC is a non-brainer anymore. All right, so stand-up bots, great, of course, for co-located teams that are sitting in the same office, for distributed teams. But what is with if you work in different time zones, that you hardly have an overlap? We also thought about that. So we have this bot that is taking all our information from stand-up, so we're telling them, okay, this is the status update, this is what we're doing, blah, blah, blah. It's what I've done in the day. And then, if it's getting night on your side, you can request and ask, hey, what has the team on the other side of the world been doing? And we put that, and this team actually it works in Australia and in Europe, in Gdansk, in Poland, and they have really hard time with overlapping stand-ups. So they're doing a weekly stand-up to come all together, and on a daily basis they are using this bot. And we put it into their team chat room. So this team has a chat room, and we put it into their team chat room. It's a bot there, and you just write /standup, do your report, and if you just type /standup without anything, you can see all the updates from all the team members around the world that is doing that. So pretty cool stuff. But chat bots are today everywhere. No matter what chat service you use, there are some big integrations from your system into chat. If you use HipChat or Slack, there are always integrations available, and we use them heavily. So for example, we have a build integration where we can see actually when the build fails in the chat room. And the good thing is you can immediately jump on it and ask, hey, who's fixing that build? And you have it all in one room, or deployments. You can see when a deployment happened and not be surprised of some deployments. Or if an exception happens, we use Sentry for capturing our exceptions. And Sentry is reporting back to our chat that's saying, okay, there's an exception happening on the production system. We have never seen it before, so maybe you want to have a look. And you can start a conversation and mention people and stuff like that. So actually, chatbots are everywhere. They're good and have fast feedback loops. So you get immediately feedback from your systems. It broadens the team knowledge. Everyone knows that the build fails, and everyone knows, okay, this exception happened, but Thomas is on it and fix it. So it broadens the team knowledge, and you can start a discussion right away in the tool where you saw that something failed. All right, wrap this up. 15 minutes already gone. I've been talking about the whole development phases here: coding, testing, operations. We're doing support and report, and we can use bots to help us in every phase here to spend more time on solving the real problems, on doing coding stuff. And you might think, hey, all these cool bots, where can I download them? And I talked to a lot of people, and they said, well, there are a lot of bots out there if you go on Bitbucket or GitHub and look for some code. So there are a lot of bots out there, but there's also a lot of unmaintained projects out there. So you find something and you have to code it anyway, understand the code, and code it anyway from you. And a lot of bots are solving a very, very unique problem that this team had or has, and you have to adapt it. So a lot of people are ending up writing their bots from scratch anyway. But the most problem that we have with automation, what's that? It's the time. We never find time to write automating code. We have sprint goals and stuff like that. We don't want to let people down on sprint goals and take time for writing automation code. But hey, what we're doing as software developers is we're automating stuff for other people. Why do we don't just take time to automate stuff for ourselves? Let me tell you a story here. So, as I said, Jira, very old product, and we have a lot of technical debt that we are carrying with us. And our engineering leads, they say, okay, good, let's work on that technical debt. So what you get is 10% of your sprint time you can use for better engineering health. So improve it, refactor in 10% of the time, and make things better, smoother, and stuff like that. So it's better, more maintainable code that we have. But what a guy did in Gdansk, in Poland, Philip, is not spending the time for writing, for actually refactoring and making the engineering heads better. He actually wrote this Dr. Code bot for automating the engineering health. And now everyone wants to be in the Hall of Shame, and everyone wants to be in the Hall of Fame. So everyone is taking the time during normal sprint time to make the code better. Or we use so what we also do is we have quarterly hackathons for 24 hours where we try to improve our product, stuff like that, trying things out for innovation. But what we also do is we look at our software development and come up with better processes and do some automating stuff in that too. So having hackathon, and actually someone suggested to have an automation hackathon just one time and doing some cool stuff that helps us in our software development. All right, but working with bots and working with automation scripts, treat those scripts well. Treat them as this is your production code. So first, put everything under source control, even if it's just a small cron job that you're running, put that under source control so everyone is aware of that and you can track down changes if you do. Do code reviews. Spread the knowledge of your automation code too. So spread the knowledge in your team. So do code reviews also for your automation code. Write tests also for automation code. If someone else has to change the code, you want to be sure that he or she didn't mess anything up. So write tests for that. And also pretty important, have deployment scripts. So that you put in the credentials for the server and you know which servers this code has to deploy to. Not everyone knows that. So having deployment scripts is pretty essential for also automation scripts or bots or whatever you call that. At the end, we are engineers. And building software is a craft. We are craftsmanship. And it's like with every craftsmanship is that we can have tools to help us to automate stuff, to help us to build stuff. There's the possibility to automate some stuff. But we're also creating customer value. And this is really an art. The time we save here, we should spend into creating better customer value or more customer value. And this is really hard to automate. And there's the place where bots will not take over in the near future. They can just give us advices where to look after and where we can improve our services. But this is really where we use our brains, where bots can't really help us. So, but first, the last thing I want to stop this talk with is a little bit a warning here. Don't mess with your bots, treat them well. And we shouldn't treat our bots just like this. You think it's funny, the bot doesn't think it's funny, so please treat your bots well. Don't do that with your bot or that with your bot, because we know what happens when we do that. Skynet comes, takes over everything, takes over the world, takes over our job, so please don't let that happen, and well, that's the rise of the machines. Thank you very much. All right. Should we take some time for questions, or should we just use the break and you can come to me? What do you think? Questions? There in the back.
How many hours do you work
How many hours do I work in a day? How do we find so much time to do this kind of jobs? Yeah, well, so that's a pretty good question. As I said, we're taking the time during our Ship It days, for example, which is really for innovation and for doing these kind of stuff. But also, I think it's important to put that into your sprint goals. Maybe allocate some time in your sprint goals where you say, okay, good, 20% of our sprint goal we're using on automation, or make the code more maintainable, stuff like that. I think it's pretty important for us that we just don't run after sprint goals, but we also look at what can we make better. So it's a kind of an agile thing. I mean, continuous improving, not just, continuous improving ourselves and our jobs, to take that time that we save with the automation, to use that to create more customer value. That's just it. I can't really say something, so just use your time for automation, pretty important. Don't overuse your time, because sometimes maybe this automation doesn't really have a real big impact. So don't overuse that, just allocate some time, and always think about what will the outcome be if we have that, if we invest time in here, what will the outcome be? Will really save us time at the end, so do that. All right, if there's no further questions, well, there's one in the end back.
Where can I find the Robo Was It Right t-shirt?
Where can you find my, well, fuck me, the Robo Was Right t-shirt? Well, I didn't get one, otherwise I would wear one. It's just the people that worked on Hercules that get one, so that's a very exclusive t-shirt that not everyone gets, so sorry. No t-shirt for you, my friend. So I'm here the whole day, so come to me, approach me, and have a great Walks Days Istanbul. Thank you.